Imagine a world where simple rules can create breathtaking, complex patterns. Welcome to OmniCA, a tool designed for anyone curious about exploring the beauty of cellular automata. With just a few clicks, you can design unique simulations, experiment with evolving patterns, and uncover the surprising behaviors hidden in these digital systems. Whether you're an artist, a programmer, or just someone who loves discovering new things, OmniCA invites you to dive in and explore the infinite possibilities of cellular automata. To get started, first locate the Simulation Manager in the hierarchy and select it. This will give you access to the CA Manager component in the inspector. Here, you can adjust the size of the simulation field using the resolution slider. You can also control the speed of the simulation by setting the delay field, which represents the time between steps in seconds. Need to pause or go step by step? You can easily pause the simulation and manually advance it one step at a time. You can also restart the simulation at any point with the click of a button. Importantly, there's a button to open the rule editor and a fold-out option where you can configure rule chains for more complex simulations. Now let's dive into the rule editor. To open it, simply click the Open Rule Editor button. The editor is divided into two sides, the left and the right. On the left side, there are two main sections, File and Table. File is where you can save, load, or create new rule files. Below the buttons, you'll find an input field combined with a drop-down list of existing rules. You can either enter a new name, or select an existing one to save your rule under a different name. The Table section is the core of the rule editor. Here, you'll see a scrollable view of all possible neighborhood configurations, displayed as grid-like icons. Each grid represents a possible configuration, and the checkbox next to it controls whether the central cell will be active, highlighted in cyan. By setting or clearing the checkbox, you define how the cell will behave when this specific neighborhood is encountered. On the right side, there are four sections: Search, Script, Binary, and Integers. Search lets you quickly find any neighborhood configuration by clicking on the cells in the grid. It works like a switch: click an empty cell to fill it, and click again to clear it. Once the configuration is selected, you can set or clear the next state of the central cell, which updates the rule accordingly. In the Script section, you can generate rules using a script. Just select a script from the drop-down and click Run. To create custom scripts, you'll need to extend the Rule Builder class. Check out the existing scripts for guidance. The Binary section displays the current rule in a compact, bitwise format. It reflects the state of the table on the left, showing each configuration status. For example, if configuration number 5 is set to true, you'll see a 1 in that position within the binary section. Finally, the integers section shows how the rule is stored in memory, 16 integers representing 512 bits, which is the full size of the rule. Next, let's explore the Rule Chain field, which allows you to experiment with changing rules dynamically within a single simulation session. Start by clicking on the Q drop-down. Here, you can choose how the rules will cycle, in order, repeat, or random. On the left side of each rule element, you'll find a drop-down list of saved rules from the Rules editor. You can also select Use Latest to apply the most recent unsaved rule. On the right side, you can set how many steps the simulation will take before switching to the next rule. Set it to 0 for an unlimited number of steps before a rule change occurs. This feature gives you flexibility to experiment with evolving patterns by chaining together different rules, letting you see how the simulation behaves with varying conditions. Now let's talk about the Field Initializer, which lets you set the starting configuration for your simulation. To begin, select a field initializer from the available options. The standard choices include center, grid, noise, and paint. If you want to add new initializers or modify the existing ones, you can find them in the Assets or Data or Field Initializers folder. For example, the Paint Field Initializer allows you to paint the initial configuration in a dedicated window or use a .png file by loading it through the texture field. This gives you even more control over how your simulation starts. To create a custom initializer, simply create a class that derives from Field Initializer. Refer to the existing initializers for guidance if needed. And that's it. You're now ready to explore OmniCA and create your own unique simulations. Check out our website for more details, and if this video helped, don't forget to like and subscribe. Thanks for watching.